Okay, so this lesson is all about domain and range from an equation. But before we get into that, I want to talk briefly about a couple of the parent functions that are in this lesson. This first one is the absolute value function, f of x equals absolute value of x. And you can see the shape of the graph. And the domain is all real numbers. X is an element of the real number set. And the range is 0 and all positive y values. So it's y is an element of the real number set such that y is greater than or equal to 0. And there's much more detailed information in the lesson. I would encourage you to take a look at that and take some notes on it. This other parent function is the square root function, f of x equals square root of x. And in this case, both the domain and range are 0 and all positive real numbers. So domain is x is an element of the real number set such that x is greater than or equal to 0. Range, y is an element of the real number set such that y is greater than or equal to 0. And once again, the lesson has a lot more detailed information. Take a look, take some good notes. Okay, so now let's talk about domain and range given an equation. So this equation, f of x equals 1 over x plus 1. The first thing you want to do is actually make a graph of the function, just so you can get an idea of what it looks like. Okay, so it looks like there's a vertical asymptote at x equals -1 roughly, and maybe a horizontal asymptote at y equals 0, just by looking at the graph. And when you're looking at a rational function, the numbers that aren't included in the domain are going to be the numbers that make the fraction equal to 0. So basically x plus 1 equals 0 tells you where the vertical asymptotes are, and those won't be in the domain. So if you solve that, you get x equals -1. So that tells me that in set builder notation, the domain is going to be x is an element of the real number set such that x is not equal to -1. It's much easier to put not equal to -1 than to try and put all the values that it can be. So this works right here. And the graph does not hit 0. It does approach in both directions. So the range is this. Y is an element of the real number set such that y is not equal to 0. Okay, so that's set builder notation. What about interval notation? Well, for the domain, start there, comes from the left, minus infinity, because it goes forever in the negative direction. And then it approaches -1, but never hits it. So -1 is the upper bound, but it's open because you're not including the -1. There's another set for the domain, all the values for x to the right of the asymptote. So that is -1, infinity. And you put those together with a union symbol, like this. Okay, so this is interval notation, how you say x is an element of the real number set such that x is not equal to -1. You just say open interval -infinity, -1, union, that's what that u is, union with open interval -1, infinity. And for the range, exact same idea, except this time the y value you're not hitting is 0, so this is what you write it as. Open interval -infinity, 0, union with open interval 0, infinity. Okay, let's take a look at another function. This is a square root function. And for a square root function, the undefined values are those that make the square root negative. So that means x minus 3 has to be greater than or equal to 0 for the function to be defined. So solving that, I get x is greater than or equal to 3. Okay, so then what you can do with this, you know that x has to be greater than or equal to 3 for the function to be defined. And by the way, that's why it kind of dead ends here at 3 and only goes to the right. So for set builder, x is an element of the real number set such that x is greater than or equal to 3. y is an element of the real number set such that y is, and looking at the graph, it looks like you're only having the positive values for y and 0. So y is greater than or equal to 0. Okay, now I'm going to leave it up to you to see if you can figure out how to do the interval notation based on that last example. But that is the big picture for this lesson.